A lot of them don't understand what it means. They don't understand the underlying hardware. So I asked them, did you ever look at the code?
Inspiring the evolution of embedded design since 1988.
We're joined today by Rolf Segger. I'm very excited about this particular conversation because we're going to touch on several of the issues that are important to our readers. But Rolf, first, thank you for joining us today.
Well, thank you for having me. Thank you for the opportunity. Good to see you,
Well,
Chris.
it is possible that some of our listeners don't know you, so could you begin by telling us a bit about yourself? How did you come to be sitting in the chair opposite me this morning?
My background, so I'm the founder of Sega microcontroller, and I always liked small computers, so this is how I started the whole business. So I'm 59 years old. When I started when I was like 14, I had my first computer, a Sinclair ZX80 at the time, 1 kilobyte of RAM, and anyhow, I'm not going to bore you with the details, but that's how I started, like very, very little RAM. I doubled the RAM capacity at the time. So I'm familiar with writing programs really, really small, and I just love this stuff. So then later on, I got an Apple II, plenty of memory at the time. So I'm familiar with writing small programs, and then I just started working in that area. I wrote programs for various companies. And then I found that whatever I wrote, so I started to write like for my own use, a real-time operating system. And I found that if I can use it I could use it across different projects, vastly different, like completely different. And I said, well, if I can use it across different projects, then other people can probably use it as well. So I turned this into a product, which wasn't easy at the time because the internet didn't even exist. People were still talking about the Datenautobahn, the data autobahn in Germany. In any case, so I developed the operating system, then other middleware components that we are still obviously in improved and advanced form, but we're still selling today.
And we're trying to be the one-stop solution. So whatever a company needs in the embedded field, we have it all, and we keep growing.
My company today has like 80 people. We're doing well, and we have like 4 product groups. So we have the middleware, that is the historic field. So that is a real-time operating system, a graphic software, a file system. But it's also encryption library, it's USB software, MUSB, it's TCP software, so MNet, Internet of Things type of thing. It's various components, pretty much everything that you need, the building blocks for embedded systems. We also bundle the whole thing as Empower OS. So that's one cornerstone, but we have basically 4 different product groups these days. So that's the middleware field, historically the first one we had. Then we started doing Flash programmers. The reason for that was basically Mitsubishi brought a MCU to the market, which is really good at the time, M16C, 16-bit MCU with a 256 kilobytes of flash, which was a lot at the time, but they didn't bring the programmer on the market at the same time. So we developed a programmer for them. And that over time has developed into our Flasher product group. So I look like this or like this. In-system programmers, extremely flexible. The other thing is we discovered at some point that debug probes were, the time for ARM cores. There wasn't much out there, much that was affordable and reliable. This is maybe 20-some years ago, 22 years ago, the people were using parallel port wigglers. And so we came out with a J-Link, small box, black housing, USB interface. And that has become a very popular option in the field of debug probes. Somewhat related, the Flasher can also program, because J-Links can also do flash programming for these systems. Anyhow, so the debug probes is the field number 3, and the other one is development tools. We have Embedded Studio and System View, system monitoring tools. Those are the tools. Segger is the one-stop solution for embedded systems. Yeah, and I'm still, I'm not managing director. I'm more like overseeing things, strategic discussions, and professional greeter. And my function is professional greeter. I'm here and happy to be.
So one question I have to ask, I know that a lot of people in your position still enjoy occasionally turning their hand to a small project around the house, or do you ever do any programming these days, or have you left that part of your life behind?
Yeah, absolutely. I do. I mean, I'm not involved in a date on things on a day-to-day basis. So I usually have a bunch of emails. I go through these, and some are sales related, project related, product related, strategy related, but some are also technical. And I do every once in a while something like, for example, in the J-Link, um, I've been involved on the Flasher. I've been involved in we have this is a flasher, right? This is the inside of a flasher compact, and as you can maybe see here, the main thing is one big chip. That big chip is a Zynq Xilinx, now AMD Zynq chip. So it's an FPGA with a built-in Cortex A9, and I've developed the soft core. So it comes with two soft cores that we developed for that particular purpose. They run at 200 megahertz, and they're interface processors. They can toggle any of the pins in a 5 nanosecond in a 5 nanosecond period. So single cycle, extremely small and extremely powerful, purposely made for that. And I enjoy that, like a really small soft cores. As I said, two of those. So little projects like that I do, or also the CPU design. So as I said, there's a Cortex A9 in here, and a Cortex A9, I have to say, I'm quite impressed how powerful it actually is. A9 sounds like it's not the latest, but it's pretty powerful. We run it at like 600 megahertz, but we also added some virtual processor that I would like to talk to him about later on. And I developed most of that. Actually, I work very closely with my friend Paul Curtis, and he wrote the compiler for it. I wrote most of the executor for it. We optimized it together. But yeah, I do little projects. I do little like fun projects.
It comes to mind as you were holding up the board there and talking about the Cortex. From the time that you began in the industry until now, we have seen massive leaps in the power of the processors that are being employed in embedded systems. I mean, when I began, we were using things like 8052s to do embedded work. And today is just an entirely different world. Do you find that developing for these more powerful processors is also a different thing than developing for those early processors? I mean, I assume that you no longer have to worry about precise bit counts on how big your code can be, given the relative hectares of space that you can employ in memory.
Well, first of all, I think it's easier these days. It's a lot easier, right? Because you don't have to worry about things anymore. As you said, a couple of bytes, even a couple of kilobytes of RAM, you don't typically have to worry about these days. So it's easier than programming your 8051s, and you can have multitasking. Your 8051s weren't even re-entrant, right? So you couldn't even enter the same function a second time. There was like static overlay scheme. So things couldn't even be re-entrant, let alone that you could have multitasking, and you have all of these things today. So I think it has gotten a lot easier, but it's also where people no longer, like junior programmers, a lot of them don't understand what it means. They don't understand the underlying hardware. So when I hire people, a lot of times I ask them, did you ever look at the code that the compiler produces? And the typical answer is no. Or you know what registers are used, what a calling convention is. The typical answer is no. And it leads to some things. I remember when we started to develop our debugger. We have Ozone, right? And for our J-Links, our J-Trace probes, and we need our own debugger for that. Initially it was supported, J-Link was just supported by other IDEs, but we said we need to, in order to fully show what this thing can do and you take advantage of all of the features, we need to have our own software, our own debugger. So we started to develop Ozone, and the guy who developed it, it's based on Qt, so there's a lot of C++ in there. He was developing it, and he had a memory window, and it was, I mean, you could basically watch this thing being as it rendered. And I looked at the code, and what he had done is like So he uses a C string and adds every character, and basically every time you add a character, it gets reallocated. So if people don't know how things work under the hood, then they tend to write, the risk is there of writing inefficient code. So people these days don't really know that much anymore how things work under the hood. But basically, it's easier.
Because you and I have the same basic hairstyle, we've been around a little while. I'm going to
Great
ask
hairstyle,
this.
by the way.
Thank you, thank you. How much do you think it matters? I mean,
The
are
hairstyle?
the hairstyle, obviously, but you're talking about the junior programmers who come in, who have probably never written in assembler, never really looked at the nuts and bolts of how the software is executing. Are the processors we're dealing with now sufficiently powerful to make that unnecessary knowledge, or is that something that you feel is still an advantage for a developer to be aware of?
I think it's a great advantage to be aware of it. But yeah, obviously it depends on what you do. If you write a little utility, you can do all you want. It's gonna run fast anyhow. You write a little utility on your PC, and a lot of software components aren't really critical, but some are, right? And what happens, people don't really know. A lot of people don't know how to make it efficient, how to keep the size small. So as long as you have a senior developer overlooking things, it's okay. But it's definitely still an advantage if you know how things work under the hood and how you can make a memory efficient, and most of all efficient in terms of execution, in terms of performance. But also, in the embedded world, it depends on what you're doing. If you build something that has external memory anyhow, right, a large amount of memory, then size is not a big issue. If you build something that you're selling in large quantities, millions a year, then every byte counts. It does make a difference. If you have to go from the 64K device to the 128K device, and you're paying 10 cents more, but you're building 5 million units, it's 500,000 at the end of the year. So it does matter. So yeah, I think it's still good to know that. But especially for large systems, you can treat them like a PC, and you can program them in C++, and for a lot of things, performance is not that critical. But on the other side, sometimes I wonder, I start software on my PC and it takes seconds. And like, what do these people do? Like, how do they waste so much memory and compute?
One of the things that you said in your last answer is interesting to me, because you talk about the dynamics and the economics that change depending on whether you're designing a project that will ultimately have 1 or 100 or 1,000,000 units.
Absolutely.
You're at an interesting place in the industry to see some of these trends. And I remember conversations with engineers on teams I was part of where, are we going to go with an ASIC? Are we going to do an FPGA? Are we going to do a microcontroller with flash memory adjacent? Is this a conversation that you still see going on in the industry? Is there still room for all of these memory types with their associated controller brain power, if you will?
Okay. Yeah, I think there's still room for all of these, just like there's room for 8-bit processors, for example. If you do something really small, call it a sensor, and all it has to do is send one value every once in a while, there's no need for a 32-bit CPU. And yeah, if you build small quantities, then maybe putting a big memory on and making it more expensive, but reducing your development cost, because you can just put anyone on there. You can put a Linux on there and don't worry about it. Might be a good option. So it really depends on your quantities. But I enjoy building things small and efficient, right? And both from a cost perspective as well, like from a power saving perspective. But there's room for all of those, yes.
Well, when you're developing, you've talked a couple of times about developing the software. And I know that you also at Segger have your development systems that you provide to the industry. And I will tell people you can get the Segger editor at no cost from Segger, and I have downloaded it, and it is a fabulous interface to work within. The world of development seems to be changing in several ways. We're both seeing more boards come out that have multiple processors on them, perhaps a microprocessor and a microcontroller in the case of something like the Arduino Q and the boards that are following in its footsteps. And we're also getting the AI assisted development. What do you see coming? I mean, as someone who builds these systems, who has to have an eye on what's going on in trends in development for embedded systems, do you see changes coming in how programmers do development for embedded systems?
I mean, definitely the trend you mentioned is the multi-core, right? Multi-core is, and it's not a brand new thing. I mean, we had multi-cores 5 or 10 years ago, but I think that's getting more and more prolific. We're gonna see more and more of these. If I take this example here again, right? This is actually, you get the same thing as a dual core. For cost reasons, we decided to use a single core, but we have multi-core because we put the other cores in the FPGA fabric, right, as soft cores. And the benefits are clear. I mean, if I need to guarantee, for example, I talked about the soft cores that run at 200 megahertz, and those run independent, so I can guarantee a 5 nanosecond timing. And if I run everything on a single core, that single core will get an interrupt, right? And that interrupt, we can make it quick, and it's maybe a microsecond or maybe it's 5 microsecond. But if you have a timing critical protocol, even that 1 microsecond isn't good enough, right? So in order to guarantee reaction times and perfect performance, having multiple cores is a good thing. Unfortunately, it also adds to the complexity. But yeah, I think multi-cores are becoming, I mean, multi-cores are there, they're becoming more and more mainstream. And the core doesn't, if you look at a chip, if you take a look at the die shot, the memories of microcontrollers, typically the memory is what eats up the most. And the CPU in comparison isn't that big. So if you add a second core, you're making, you need maybe 1 or 2% additional die space. So it doesn't really cost a lot. It doesn't, in comparison to the additional memory, it doesn't really cost a lot. Yeah, and on the MPU side, you know, we had this discussion before, microcontroller and microprocessor, to me, a microprocessor was always something that doesn't have internal memory, has external memory, and the microcontroller has everything built in. And microprocessors these days typically run Linux or Arduino, Linux or Android or something. So where the microprocessors, the microcontrollers typically don't, because with their internal memory is expensive. You can have a megabyte, you can have 2 megabytes, you can have 4 or more, but to run Linux, you need a lot of memory, and it really makes it's typically too much for microcontrollers. So we see applications where people run like a Linux or Android on the main processor, on their microcontroller, and then on the microprocessor, the powerful core on the microcontroller does more of the real-time stuff.
Well, Rolf, I fear that we're coming towards the end of our time together, and I have a couple of more questions I want to ask, but the big one is if people want to know more about Segger products, where can they go to find out?
Okay, very easy, segger.com, Segger, and we have all the information there. And one thing, I guess I forgot to mention, but one really interesting thing, one of my pet projects I also worked on is exactly that, MApps. So it's a basically a virtual CPU that we're using in our flashers. And yeah, that's a brand new thing. I'd appreciate when people take a look at it, and we always appreciate feedback. And I do appreciate your time being on the show.
Well, thank you so much for taking your time to be with us. And I know that things are always changing in this industry, so I will look forward to the next time we have a chance to talk together.
Absolutely. So do I. Thank you for the time and all the best. Ciao,
Learn
ciao.
more at circuitseller.com.